Hi guys, welcome back to another video. Today we're going to be looking at the following geometry problem, and this is AMC 2016, and this is problem number 23. So let's start with a quick read, as usual. Two congruent circles centered at points A and B pass through the other circle's center. So let's just start right there. So say we have circle center A, and then we have a circle with center B, and it says that the circle passes through the center of the other one. So that's not a great drawing, but we get the idea, right? The idea is that you have two circles and each circle passes through the center of the other circle. And then it says the line containing both A and B is extended to intersect the circles at C and D. So something like this, and you have this is C and this is D right here. And then it says the circles intersect at 2 points, right, up here and down there, one of which is E, so we call the top one E, and we want to find degree measure of CED. Headline. So basically, and we can mark it in red, we want to find this angle, CED. Okay, so right away, if we kind of think about this, we can see that we don't have a direct way to find CED. And I say this probably for every problem. When you have any circle problem, I like to connect my centers to important points. And in this case, AE and BE, right? Because now what this tells us is we've drawn two radii. And we know the two circles are congruent, right? Which means they have the same radii. So let's say the radius AE, let's draw this in blue, right? That's going to equal AB because AB is also a radius. And then that equals BE because BE is also a radius. So that means that triangle AEB, because they're all radii of congruent circles, that's an equilateral triangle. So we have this is 60, this is 60, and this is 60. Okay, so that's already, we figured out one part of angle CED. And now we need to figure out these two smaller angles, right? We have to figure out this angle right in here. And then by symmetry, we know that angle, so CAE, angle CAE is going to equal angle BED. And that's just by symmetry, right? These two black angles are going to be the same. So now we just have to find one of them. So now let's go back to our idea of radius. We know that BE is a radius, so that means BD is also a radius, right? Because remember, B is the center of our circle, right? If we draw this, that's a center. So that means I have triangle EBD, triangle EBD is isosceles, right? Because two of the sides are the same. And now if this right here is 60, this would be 120 because they have to add up to a straight line. So basically, if I pull this triangle out so it's not as cluttered, I have this vertex angle is 120, which makes both of my smaller angles 30. And I know that's kind of hard to see, but we have this is 30 right here. And again, by symmetry, let's just draw this in red. Okay, that's basically we have this other angle right in here is also 30 degrees. So ultimately, if I kind of draw this a little bigger, we have angle CED, which is what we want to find, CED, and we split it up into three parts. One of the parts was 60, the other two are 30. So that means the total is 30 plus 60 plus 30, which is 120. And if we look back at our answers, that corresponds to answer choice C. So that should be all for the question today. If you have any questions on how we solve this, please leave a comment. And if you enjoyed the video, like and subscribe, it really helps us out. But that should be all. So thanks to everyone for joining, and happy Thanksgiving for those of you that celebrate. Bye.